When we want to calculate solutions to differential equations, there's a few things we can do, but often we need to start by approximating, and it's nice to be able to get a look at it. So that's where slope fields come in. We've talked about them before. We're going to look at them a little more in detail now just to see how they are used. So here, consider this differential equation. dy dx is negative x over 2y. Sketch a slope field of the differential equation on the coordinate plane below. So we've got all these points, and we're just going to plug them in. So for example, here, 0, 0. 0, 0 doesn't make sense for that because you can't have 0 divided by 0. But if we take the point x is 0, y is 1, we get 0. So the slope is 0. X is 0, y is 2, the slope is 0. The slope is 0, the slope is 0. If y is 0, everywhere along here where y is 0, it's undefined and it's not going to work. How about at the point 1, 1? If x is 1, we get negative 1, and y is 1, we get 2. So let's put some points here. 1, 1 maps to negative 1/2. So at 1, 1, we have a slope of negative 1/2. I kind of look at this up 1 over 2, kind of aim it along that. Negative 1/2. At the points 1, 2, we get negative 1/4. So now it's not even that steep. It's like here, negative 1/4. If we switch it over and do negative 1, 1, and negative 1, 2, well, that just changes them to positive. And so we have positive 1/4 and positive 1/2. But this gives us kind of a picture of what this graph is going to look like. And this is our family of graphs. So part B says, okay, let's do a possible solution for the thing that passes through 0, 1. So what we're going to do is we're going to go to 0, 1, and we're going to say, okay, our curve goes through here. What's it going to do? Well, if we just follow the curve along out to the next point, we get to here, and then we see, oh, now I'm supposed to go to slope of 1/2. So we go to slope of 1/2. When I get to here, I'm at 2.5. So I get negative 2 over 1 is negative 2. So now I have a slope of negative 2. But I can see that it's going to kind of mirror back here. And hopefully you can kind of follow what I do. Basically, you're just kind of taking sketches. And now at first I went from here, I went 1 all the way over, but really it's going to be tweaking all the way along. And so we're going to end up with this ellipse type shape. And there's our solution here. There's our sketch of a possible curve. Now let's see if we can find a particular solution. We have dy dx equals negative x over 2y. How can we solve this to find out what y is? Well, the first thing we need to do is we need to separate our variables. And so we're going to multiply by 2y. We're going to bring the dx over, and this is going to become 2y dy equals negative x dx. Once we've done that, now we can take the integral on both sides. And if we take the integral on both sides, this becomes, the integral of 2y is y squared. The integral of negative x is negative x squared over 2. and then we'll go ahead and put our plus c on this side. Technically, that can go on either side. We just don't need it on both because they cancel each other out. Particular solution goes through 0, 1. So we get 1 when x is 0. So c is 1. I'll go ahead and do that. 0 plus c. So c equals 1. And so our particular solution is that y squared equals negative x squared over 2 plus 1. If you want, we could take the square root, but we will just leave it as that. And there is our particular solution for this differential equation that passes through the point 0, 1.